probably would have been helpful. Yeah, exactly. I have also a feeling, which will be somewhat embarrassing, that if your algorithm was one person, just count everybody in all the rows, they probably could have done it in 2 minutes. What else did you notice about this? Yeah.
I think we need a lot of communication saying that, hey, do empty here and that kind of stuff.
Yeah, so you kind of had an allocation problem. You also had a big data movement problem just to get everybody into the appropriate seats. So I actually think in hindsight that groups of 10 might have actually gotten people to a countable set a little bit quicker because you didn't have these dependencies to get everybody in rows. So I have a feeling that if you're getting hot and things like that, why don't you file back to wherever you feel most comfortable. But thank you very much. So if I assume there's 160 of you here right now, that was only 10 times more work than we originally asked to do, for example, right? And so it shouldn't have been more than about 6 or 7 minutes to add it all up sequentially. It should have been much less because now it's just +1. It's not adding a harder number. But we were nowhere close to that, right? In terms of a 100x speed up over the sequential algorithm. And it was largely because of the cost of communication, synchronization, moving all of you. And so this is something I want you to keep in mind because although the class is about parallelism, I mean, the reality is that it's really about moving things around. Every system that I think I've ever built, I bet Kume probably would agree, is kind of the only thing that really matters is communicating and moving stuff around. Okay, so let me get into just some summary and some logistics real quick. Theme number 1 of this course is we're going to get you thinking kind of like you were just thinking now. We're going to give you problems. You need to compute this problem, and you need to do it as efficiently as possible. And so we're going to want you thinking about how to decompose things in parallel and how to synchronize. And we're going to, I like that there's some folks interested in the hardware-software boundary because we're going to talk about programming mechanisms that help you organize that thinking, that make it a little bit easier to solve problems like this. Now, some of you are computer scientists, your day jobs, or you write software. Some of you are EE and design hardware. Another aspect of this course is about the fundamentals of how hardware works, because you can't make things go fast if you don't know how things are running under the hood. So the hardware is a little bit about why code has to be structured in certain ways in order to run fast. So software people, hardware designers need to know about hardware because they like to build this stuff. Software folks need to know a little bit about hardware to go, wait a minute, why am I making my program structured this way? It seems hard or it seems difficult. Why can't I write it in another way? And more so than in previous years, there's going to be a stronger component in this class of actually designing hardware itself. So there may be an extra credit assignment at the end of the quarter where you can actually make a piece of hardware on an FPGA or some programmable substrate. And then the last thing I want to just really emphasize is I care a lot about teaching people about efficiency. In some cases, in this exercise where we added up the number of people in the room, if it would have been easier for one person just to scan the rows and add them all up, that's great. That's a faster, potentially more efficient solution than a solution that was highly parallel but had a lot of communication. So let's not get too hung up on parallelism because efficiency is often what matters. So here's an example. Imagine that you go off to your next internship or full-time job or whatever, and you were asked to write, to speed up a program on a 10-core processor, something like that. And you came back a month later, and you were able to get 2x speed up. You went to your boss, you said, look, it's 2 times faster. Do you get fired? Or do you get a raise? Okay, so we have a very negative class. Some people want to fire you. What's a rationale for getting fired?
I mean, you had 10 processors, but all you could achieve was a 2x speed up.
You had 10 processors, you only got 2x out of it. Maybe you're using those processors very inefficiently. They say, you're fired. Go back, take CS149. Any reason to give the person a raise? Yes, sir?
Yeah.
I'm just saying not all programs are so easily parallelized.
Like the one we just did, right? That's a pretty hard program to parallelize. Is there a reason why you might be satisfied with 2x?
Yeah, if the performance gains by that offset the additional cost of using a 10 processor computer.
Yeah, like maybe computers are cheap and like being able to reduce the response time of your website by a factor of 2 translates into a ton of sales. You might be really happy. Or like Google search results have to be returned in a certain amount of time, otherwise people lose interest and go somewhere else. Another example, imagine you had a computer game that ran at 15 frames per second in a game, and you made it get to 30 frames per second. That might be the difference between the game shipping or not shipping, right? So sometimes we care about raw performance. Sometimes we care about efficiency. Ideally, we'd like to have both. Okay. Okay. Yeah, and hardware designers care a lot about efficiency because they're like, the more hardware we put into the chip, the more expensive this chip is going to be to manufacture. So I'd like to put in the minimal amount of hardware that I can get by with and still meet my performance goals. Okay. All right. Middle of the lecture, let's take a breather for a second and just go through some logistics. This would be a good time to ask any questions about logistics. Getting started is that all information on the course will be via the website. So CS149, here's the website. All the lectures are posted. So we try and make sure that your lecture slides are posted prior to lectures so you can follow along while you're in the classroom. Notice that there's a mechanism to comment under the slides. So you can add a comment. And typically, the reason why we do this under the slides is you can ask an actual question specific to the slide. So like intellectual questions, like I didn't understand this, can someone explain multi-threading? Very much prefer them to come in via the slides so that other people can see them and respond, as opposed to making those on Ed. Ed is for like logistics and stuff like that to me. And you can always go up here to the course feed and see all the comments that people have made. Okay, back to my lectures. So that's that. There's no textbook. The slides are basically the textbook. The internet is full of great resources, and so a great way to make a helpful comment would be to say, hey, I actually learned it from this website. The explanation in class was pretty bogus. This is way better. Go read this, right? All right, so you're going to be doing 4 programming assignments. It's the bulk of the grade. The first programming assignment will come out on Thursday. It's a little shorter. The next 3 are significantly longer. You will be writing a much more elaborate version of a thread pool where we give you dependencies and everything. You're actually going to be writing a renderer yourself that will make pretty pictures via in CUDA as fast as you can. Not made yet, but intended to do so. Assignment 4 is definitely very new this year. You're going to implement the transformer module of a DNN, and you're going to try and do it as fast as possible so that you can have a chatbot kick out tokens, and maybe we'll have all the chatbots chat with each other or something like that. Okay, so there's 4 assignments. Typically after Thanksgiving, we release a 5th, which means you can use the 5th because it's awesome and fun, or you can use the 5th to boost the score of one of those by a few points, usually about 10 or 15 points. Okay, most of your grade is there. We do written assignments that are graded on a did you make a reasonable effort. The written assignments are all previous year's exam problems. So about every 2 weeks, there'll be a written assignment plus practice problems. So we distribute practice problems throughout the quarter. You can think about this as a participation grade, largely. And then the last part of your participation grade is I do not want people studying for the final exam and not thinking at all about the course between now and the final or the midterm exam. So just to force you a little bit to engage with the lecture in the same week as the lectures, we require 1 reasonable comment per lecture, approximately, in approximately the same week as the lecture. So no hard rules on this. But I hope that you average about 2 comments per lecture throughout the quarter. And if you really like a lecture and want to do a bunch of comments on one lecture and skip the next lecture that week, that's fine. But no, it's not cool to do 35 comments when you're studying for the midterm and only then. Right? And so you can kind of see some of the interaction that happens. Like these are real comments from students before. And so we expect you to do that. And I think good architects typically write well, write clearly, not elegant English language prose, but as an architect, you're constantly communicating to other people about technical things, and I think this is a very useful thing to be doing. So you can take this offline, but here are some examples of fodder for comments. In a big class like this, the comments actually works pretty well because somebody asks a question and then other people answer it. Don't worry if someone has already answered the question. You could answer it again in your own words or something like that. There are a bunch of ways to interact. A lot of people post cool links, like I saw this on Stack Overflow. It's a great example of this concept and stuff like that. Grading distribution is here. So 58% programming assignments, that's most of it. Exams are about 30, and then these 2 participations are just like last year, about 10% of the grade. Okay. The only last thing I wanted to say now is we do 8 late days per quarter. You can use your 8 days for programming assignments or for the writtens. Most people use them for the programming assignments because the writtens are just participation. That's pretty generous. That's 8 days throughout the quarter. So we expect that those late days are for most life situations. Minor illnesses, getting busy in other stuff, taking athletic trips and things like that. I was a college athlete myself, so I understand and I'm sympathetic. But I think that the 8 late days should handle most cases without asking. If you get yourself in a situation where this is going to be trouble, come talk to us in advance. I mean, multiple days in advance. You're like, I foresee this, me not being able to complete my work. We'll handle it on a case-by-case basis. But I bet 95% of the time, I'm going to say, just use your late days. That's what they're there for. No problem if you turn in your assignment 3 or 4 days, 3 days late. I think we have a rule that programming assignments, written assignments can only be 1 day late because I want to release solutions and they're for credit only. Programming assignments, I think, can be up to 4 days late. I can't recall what it was on the website. It's 3 or 4. Okay? All right. Any questions about logistics? That's all I was going to do about logistics. Yeah.
One, not a question, but kind of a feedback. Like in both the programming and written assignments, could you indicate like which question or which component could be completed after which lecture?
Sure. Yeah, I could even do that in lecture. I mean, it's not super modular like that, actually, so it might be a little hard. But in general, the programming assignments, with the exception of assignment 1, all the content, I believe, is released prior to all the lecture content exists prior to the assignment coming out. In assignment 1, you'll have, conceptually everything you need on Thursday, and logistically, with a little bit of programming example, comes next Tuesday. But, yeah. Yes?
Will the final exam be in person?
Final exams in person.